As many of us know, replacement battery packs for DSLR cameras are not cheap, and as a result, many of us look to buy lower cost alternatives. In this video, we're going to compare the original equipment battery, a genuine one, to each one of these aftermarket batteries. These are the four most popular that are sold online. We have the ecoEfficiency, Kastar or Kastar, Powerextra, and STK. In addition to these four aftermarket batteries, there's one that I can rule out very quickly, and I'll explain why in a minute, and it's the Vivitar. The Nikon battery is an ENEL14A. The results that you're going to see in this video are going to apply to all different types of batteries for each kind of camera. So if you have a Canon, you could base the results on this video because the aftermarket battery manufacturers are going to be using the same type of lithium polymer cells in each one of the battery packs. The only difference is going to be the size that they're cut to and how much is used inside the battery pack. This one here, 7.2 volts, 1230 milliamp hour capacity, 8.9 watt hour. The cells in this battery are made in Japan. In addition to testing the brand new Nikon battery, I'm also going to be testing my old Nikon battery that's been in use for 1 year and 9 months and produced almost 80 videos. Next in line is the ecoEfficiency, 7.4 volts. They're basing the nominal voltage of the two lithium polymers inside here at 3.7 each, so that's why you're seeing 7.4. The Nikon is basing it on 3.6, which makes 7.2. You can see the milliamp hour capacity is roughly 200 milliamp hours less than the Nikon. The cells in this battery are made in China. Next we have the Kastar or Kastar. This one's showing 7.4 volts and 1700 milliamp hours. This one is also rated much higher than the Nikon at 1230. The cells are made in China. Next is the Powerextra, 7.4 volts, 1500 milliamp hours. Also much higher than the Nikon, made in China. And the last battery we'll be taking a look at is the STK brand, 7.4 volts, 1500 milliamp hours, which is higher than the OEM, and this battery uses Japanese cells. In the past, I've showed you a bunch of fake 18650 cells on my channel, and I explained to you that using lithium-ion chemistry, that you're only going to get so much energy out of a cell of this size. So this is an 18650, that means 18 millimeters wide, 65 millimeters long. If the lithium-ion cell that's used is a quality one, such as LG or Samsung, you're never going to see more than around 3500 to 3600 milliamp hour capacity. So if you see a cell like this, made by a different brand that's cheaper, and they say it's a 6000 or 8000 milliamp hour capacity, you know it's going to be a fake. And that's the same reason why I can rule out the Vivitar as one of the replacement battery packs that you should purchase. So using a quality cell in a housing of this size, you're not going to see more than roughly 12 to 1300 milliamp hour capacity. When you take a look at the much lower priced Vivitar battery, which is a 2-pack, I think for 30 bucks, so $15 a piece, you're going to see that they're showing a rating of 2300 milliamp hours. It is simply not possible using the exact same battery chemistry, which is lithium polymer, to fit inside this housing and get twice the capacity. So in my opinion, you should absolutely avoid the Vivitar because the battery capacity rating is greatly exaggerated. The first thing I want to do is take a look at the weight for each one of the batteries. We're going to start off at the Nikon first. 48.15 grams. Now the Kastar or Kastar, whichever one it is, 45.68. STK brand, 43. Let's check out Powerextra, 46.57 grams. And last is the ecoEfficiency, 40.96, which is pretty light compared to the other ones. the Nikon was the heaviest, and the ecoEfficiency was the lightest. Now let's charge up the battery and get the first test going. The same charger will be used for all the batteries. Okay, the ecoEfficiency battery is now fully charged. It's only off the charger 5 minutes. What I did is I called up Nikon to find out what the typical current drain is for my DSLR camera while filming video. You can see it set right here for the battery current test, 0.900, which is 900 milliamps. Inside this battery pack are 2 lithium polymer cells. Each one you can drain down to right around 2.8 volts. So you can see right over here it says cutoff voltage 5.6. So that's 2.8 times 2, it's 5.6. The odds are each one of these cells are not going to drain down exactly the same, but I do want to stop the test at 5.6. To get this going, I'm going to connect the positive to the pin near the end and the negative to the opposite side. With the terminals connected, you can see 8.336 is the starting voltage. When the test is complete, you're going to see the capacity right here at the top. So if it comes up at 0.5, that's 500 milliamp hours. If it comes up at 1.000, that's going to indicate 1000 milliamp hours. Test is going to start right now. Okay guys, we just completed the test, and for the ecoEfficiency we have 737 milliamp hours, and that's well below the rating. Let's try the next one. The starting voltage just a little bit higher than the ecoEfficiency. Turn it on. The test just completed for the Kastar, and we're at 874 milliamp hours, right around 150 milliamp hours higher than the ecoEfficiency. In case you're wondering, the maximum temperature of the battery packs under discharge was right around 101 degrees Fahrenheit. Now we're going to test the brand new Nikon. The Nikon battery is now connected. You can see the voltage is very similar to the other ones in that 8.3 to 8.4 range. Let's get the test going. Here you can see the capacity for the new Nikon battery at 1233 milliamp hours. Now the battery I've been using for a year and 9 months that I filmed at least 80 videos with. Here we go. And the Nikon battery that was used has an impressive 1092 milliamp hours. Now we're going to test the STK brand. Starting voltage 8.363. And this battery here, just like the Kastar, when it dropped to 3 volts instead of 2.8, the test stopped and you can see the voltage is showing 0 until you charge the battery back up. Now let's go on to the next one. The Powerextra battery is now connected up. Let's get the test going. The test for the Powerextra battery just completed, and you can see a very impressive 1073 milliamp hours. Right here in this chart, you can see that the brand new Nikon was 1233 milliamp hours, slightly exceeding the manufacturer's capacity rating. In second place was my old Nikon at 1092 milliamp hours, which is still fantastic for a year and 9 months. In third place was the Powerextra at 1073 milliamp hours, followed by the Kastar or Kastar battery, 874 milliamp hours. Then the STK brand, 760 milliamp hours. And in last place was the ecoEfficiency battery at 737 milliamp hours. In case you're wondering, there was a direct correlation between the weight of each one of the batteries and the capacity. And you can see that right here with the weights added to the chart. Over here, the top 2 batteries after the Nikon, the Powerextra and the Kastar or Kastar, they're 200 milliamp hours apart. Now what I could tell you about this battery here, in the past I purchased 2 of them, and each one of them started off just fine in the beginning, good capacity, and after about 15 to 20 cycles, the capacity dropped way off. So this one here I do not recommend for the simple fact that it's not going to hold up. This one here, I can't tell you how it's going to do in the long run, but it certainly did extremely well for this test. As far as I'm concerned, you have two choices when it comes to purchasing a battery for your camera: stick with the original equipment, or give the Powerextra battery a try. It'll do great in the beginning. Hopefully it does well after cycling it many times. If you're going to purchase an original equipment replacement by the manufacturer, I highly recommend you purchase it from the manufacturer directly, a big chain store, or a camera store. Do not purchase these on eBay or Amazon because there are so many fakes. So be very careful when making a purchase, especially if the price looks too good to be true. Now that you've seen the results from this video, you should be able to make a very informed decision when it comes to purchasing a battery for your camera. I hope you enjoyed this video. If you did, be sure to rate thumbs up, share, and check out my extensive video playlist for many other videos of interest to you. Thanks for watching.